Hello everyone, welcome to the next video in our series of lectures for AD 400. Today we're going to talk about requirements. This will be our introduction into requirements engineering and will give us a solid base for when we go into the modeling portion of the material in class. All right, so requirements engineering is going to be a series of stages from inception all the way to requirements management. So inception is going to be where you establish a basic understanding of the problem, the people who want a solution, figure out what the nature is of the solution that's desired, and then you're going to need to have that good communication between your customer and the developer. Elicitation, which you can see here, is when we get requirements or our business goals from our stakeholders. Elaboration focuses on defining a refined requirements model that identifies specific software functions, behaviors, and information. I don't know why my mouse keeps disappearing. Negotiation is where there's a negotiation between the customer and with the software engineer team to make sure that the goals are realistic. Specification is going to be your written documents, graphical models, mathematical models, usage scenarios, things like that. Validation is where you're going to be you assess all of the items that you've created for quality and consistency, such as your software should be user-friendly, or perhaps the probability of a successful unauthorized database intrusion should be less than 0.001%, things like that. The problem is that, the software should be user-friendly. That validation requirement lacks specificity, making it challenging for there to be a quantitative measure to assess, whereas the second requirement is very quantitative, and we can definitely know that when we reach that, we will have accomplished our goal and validated it. Requirements management is where we have a set of traceability activities to help the project team identify, control, and track requirements and their changes. So it's just continuing to have a model that's tracking changes that happen in the project. Oh, okay. So this is just for you and you to look at. It's basically the same thing that I just said. All right, so the first requirements we're going to look at are non-functional requirements. And these are quality attributes, performance attributes, security, anything that has to do with the operation of the program or software, and doesn't have to do with the functional portions of the software, like the functional requirements, which we'll talk about later. So there's a two-phase process to determine which NFRs are compatible, and I'm going to walk you through this process because this is what you're going to be doing for your project. But the idea is you're going to create a matrix with your NFRs, columns, headings, and then system secure software engineering guidelines as your rows. And then you're just going to prioritize each NFR using a bunch of decision rules about which one to implement. And you'll get basically a list of the software engineering guidelines that you want to implement so that you're not being redundant or conflicting. All right, so here's some example of non-functional requirements. Again, I'm trying not to read slides, but I do want to go through these and discuss them somewhat. So here we have performance. The system should respond to user actions within 2 seconds under normal load conditions. So we've set this, we have this non-functional requirement of performance, and then we have this limitation or this goal that we have around what we want our system to do. And notice how we have a quantitative measure here. So that's really great. We can measure that. We know if we've achieved it or not. Scalability, so how able is it to scale if it grows in size or reduces? The system should be able to handle a 50% increase in user traffic without significant degradation in performance. It would be even better if we had a quantitative measure around what significance degradation would be. Reliability, we want our system to have as much uptime as possible. Definitely important for websites or cloud-based services. So we should have it of 99.9% and should recover from failure within 5 minutes. Measurable, quantitative. Security, the system should enforce user authentication and access control mechanisms to protect sensitive data. Here we don't really have a quantitative measurement, but we can measure whether this is being done by observing the behavior of the system. Usability, user interface should be intuitive and easy to navigate with clear instructions and error messages. So we could create some sort of quantitative survey for our users when we do some sort of user testing, or just get their opinion, and that would help us to determine if we met this. Maintainability is where the system's code should be following coding standards and be well documented to facilitate future maintenance and updates. Definitely something we can just observe whether documents are being created. Also, we could have people that are reporting in on their coding reviews or technical reviews. Compatibility, we want our system to be as compatible as possible with Chrome, Firefox, Safari, Windows, Mac OS X, OS, and Linux. So that can be tested as well in a more qualitative manner. Compliance, we want it to adhere to specific industry-specific guidelines. So if we're in healthcare, we want it to conform to HIPAA rules, which are protecting patients' privacy. GDPR for data protection. So it depends on really what sort of software, what's the software doing for us to know what we're going to be using for compliance. Availability, system should be available to users 24/7, scheduled downtime communicated in advance. And then accessibility, it should be accessible to users with disabilities following specific accessibility standards. Okay, so these are examples of non-functional requirements. These are the 10 most common and the ones you'll be using in your project. Okay, so what are the software engineering guidelines? This is an example of 25 software engineering guidelines, and you can look on your you can look in your instructions, and it talks to you for the project, and it goes through descriptions of each one of these. You'll have to do a little research on your project as well, because you'll want to pick a minimum of 10 of these for your project to use in your matrix. Some of these are some obvious, like we want secure communication. I'm gonna get my mouse. Secure communication, disaster recovery and backup, right? In case our servers go down. Not really that as big of a deal if we're not on-prem. If we have cloud-based services, that's more like their responsibility. Error and exception handling, we know how that works. Things like audit trail and logging is a comprehensive logging and auditing mechanisms that tracks user activities, system events, potential security breaches. Definitely very important. So all of these have different definitions that you can go through yourself and look and see which ones that you want to use for your projects. But they're all really important as much as possible in any software project for security. Well, basically for these non-functional requirements to be met. And so that brings me to the matrix. And this is borrowed from an academic paper called Using Guidelines to Improve Quality in Software Non-Functional Attributes by M. Henneff and Lee S. Lee. So the first step you're going to do is you're going to pick your 10 guidelines or more. You can pick more if you want. You will list what the guideline type is. Do your best to list that. And then you can see we list all the non-functional requirements over here in columns. And we list whether they're positive or have a positive, neutral, or negative effect on these non-functional attributes. So you can see here that lazy initialization, which is techniques to delay the creation of objects or resources until they're actually needed, which optimizes system startup and resource allocation. This is a design pattern, and it has a negative effect on the availability of the system. It doesn't have any effect on security and has a positive effect on performance. So, you know, you're going to have to do a little research on this. Look up lazy initialization and maybe, you know, talk to ChatGPT and say, hey, how does lazy initialization affect availability? Do some research on it. Learn a little bit about it, okay? So once you get all of those in place, then you're going to take your guidelines and you're going to put them here in a column. And then you're going to put them here in all these columns, and then you're here in these rows, and then you compare them. So you can see here that G2, which is packet filter firewall, actually overlaps with layered security. So we have put in overlaps there. So we'll put in either complements, overlaps, conflicts, or independent. And so you can see that we just keep filling these up. So G4 is active redundancy, and it conflicts with a single access point. So these are things you got to think about, right? If you have active redundancy, is it going to conflict with the single access point? And then you'll continue filling all of these out until this is full. Note how the upper portion is not filled out because that just ends up being redundant. You obviously don't have to talk about if layered security, what it does with itself. And here we have layered security and packet firewall, filter firewall. Well, we've examined that here, so we don't have to fill out the upper portion. Finally, the next step is that we're going to, so you're going to take a prioritized list of your required functional attributes. And so here you can see your list, which you're going to put them in order of their priority. And then you're going to go through each one. So the first NFA is security. There are 3 guidelines that have positive effects on security, but G1 and G2 overlap, so the software engineer gets to choose between which one of those they want. So they choose G1, which is our layered security, and as a result, and we still have G3 here, right? So as a result, the final guideline sets includes G1 and G3, but it excludes G2. So we put that down here. So next, and the second NFA, we have availability, and you can see availability has G1 and G4 associated with it. G1, G4, and G5 associated with it. Positive effects on availability. We remove G1 because it's already here. We already put it in there. G4 we're going to remove because it actually conflicts with G3, so we would see a conflict there. And we'll add G5 into our availability, our checkpoint, and rollback. Next, we're going to take a look at performance. And performance is going to have G3, G6, and G7. G3 is a duplicate from before. G6 is cool. G7 has a negative effect on security, which was a previous one. So we're going to remove that, and we put G6 down here. And as you go through all 10 of these, eventually you're just going to have a final set of guidelines that you're going to use. You're going to eliminate overlapping conflicts based on the priority of your non-functional attributes. Okay, so hopefully that made sense. There could be more instruction in your project instructions, of course, and you can always reach out to me. But this is a good way for you to determine what your guidelines will be, your final set of guidelines, without having redundancy and conflicts. And of course, the paper that goes through this in detail is also on Canvas. All right, so let's just talk a little bit about what sort of actions you're going to be taking around gathering requirements. So just as a caveat a little bit here, functional requirements are going to be something a little different, and we'll talk about that. Let's see here. Yeah. So what you want to do is you want to ensure that you identify your stakeholders with your team. Who are you going to talk to, right? Who's the people you're going to be communicating with to get the requirements. Most of your non-functional requirements will probably be determined by your team once you understand what the project is. You want to have multiple points of view. You work towards collaboration. You have meetings around this. There's lots of discussion. Some of the questions you want to ask: who's behind this request for work? Who's the customer? Who will use the solution? Who's the audience? Who's the users? What's the economic benefit of a successful solution? So this is kind of like thoughts around feasibility, right? Is it going to be beneficial to us and the customer to create this? And is there another source for the solution that you need? You're going to have a collaborative requirements gathering meeting, right? And you're going to be doing this actually in the class too. So you'll be meeting with your stakeholders, which will be your customer, and you'll identify the problem, propose solutions, and negotiate. You establish rules for participation and preparation, such as, basically talking points, rules of order. You want to keep it as informal as possible. It needs to be a conversation rather than a business meeting where the rules of order are followed, but more like a conversation, a brainstorming session where people can think creatively and critically to get to a point where they understand and collaborate on these requirements. There will be some sort of definition mechanism in place. You all will have a JIRA template document that you will be working off of. Feel free to use other tools if you wish. So here's the deal. Before the collaborative requirements meeting, each person is going to make a list of what they believe the functional and non-functional requirements are. So the functional requirements are just going to be the activities that the user is doing inside of your app or your software, right? Are they logging in? Are they logging exercise? Are they sharing their exercise? Are they changing their settings? What are they doing with the system? Non-functional is on the background. It's the performance-based requirements. So the non-functional requirements will follow the list we presented earlier. They're going to require some creative simulation on the part of the creators. The good news is so in your project, you all will each have a list of functional requirements you bring to the meeting that makes sense for you, but you don't need to all have a list of non-functional requirements. Just one list of non-functional requirements and the matrix completed by somebody on your team or two people on your team. However you all want to divide it up, keep in mind there are specific roles. You have your Scrum Master, you have your product owner, and you have your two team members. So think about what sort of roles that they have, and then you would ensure that they get those done. There may be some guidance on this in the project as well, so make sure you read the instructions. Finally, let's talk a little bit about Elicitation work products. So these are the products that are actually produced, such as the documentation, and a lot of these things I believe that you would have done by now because that was in a previous milestone. So project overview and feasibility is going to be our statement of our need or feasibility. It's bounded by the scope of the system or the product. So the scope, remember, is what can we do, what can't we do, or what will we do, what won't we do, right? You want to ensure there's a boundary on what tasks you're going to be completing, so there's not like a feature bloat or a scope bloat where people just keep adding features and the project's timeline just keeps growing. Stakeholder roster, where you're going to have a list of customers, users, stakeholders participate in the requirements gathering. Technical environment, so you'll want to have a description of the system's technical environment. So, getting creative here, especially for simulations, is required, but definitely in a real world experience, there would be a very specific set of technical requirement specs. Requirements is your list of requirements. We've talked about that for the whole time here. Something to keep in mind is that when you're out there in the field, you could be working for tech, you could be working for telecommunications, you could be working for healthcare. The domain is going to also apply constraints to this as well. And so use case and swim lane diagrams are something that we're going to get into, but basically these are usage scenarios that you define that give you insight onto how the system is going to operate and how the product will work under different conditions. So that's pretty much it for this video. I'm going to go a lot deeper into functional requirements and modeling in class, but this is a good intro. I think you have enough here to get started on your non-functional requirements matrix and process, and I will see you in the next video.